Okay, so let's create our table of summary. In ln of 3 and 0, the first derivative is 0. Second derivative is 0 here. In terms of where it's positive and negative, we already determined that from 0 to ln 3 is negative. It's positive everywhere else. The second derivative, the sign is totally determined by this. So when you solve this, you get this. Meaning to the right of this is going to be positive. To the left is going to be negative. Curvature analysis, it's going up, but concaving down. It's going down, 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 up, up, up. And from it, we can conclude that this is a local maximum. And it's a minimum. So we can plug in 0 to get the local maximum. It's 1 minus 3, you get negative 2. And when you plug in ln of 3, you get 3 minus 3 times e to the power minus ln of 3 minus 4 ln of 3. So 3, this is going to equal to 3 to the power of negative 1 and 4 times ln of 3. That's equal to negative 1. You get approximately 2.4, minus 2.4, approximately. Okay, we'll do one more thing, and it's asymptote analysis, right? Or end behavior. As x approaches infinity, we get y is equal to e to the power of infinity minus 3 e to the power minus infinity minus 4 times infinity. So that's clearly approaching 0. And this we can argue that, so essentially e to the power of x minus 4 to the power of x. If you factor out e to the power of x, you get 4x over e to the power of x. And if you use L'Hopital's rule on this, you can show that this is infinity 1 minus approaching 0. So it essentially becomes infinity times by 1. So we have this whole thing is approaching infinity. So I can conclude from it. So I was kind of rough there with the L'Hopital's rules. Make sure if you're not sure about this, go back to L'Hopital's rule. Your L'Hopital's rule fundamental is strong. So as x approaches infinity, y is approaching infinity. Let's try x approaches minus infinity. And then you get y is equal to e to the power minus infinity minus 3 e to the power minus of minus infinity minus 4 minus infinity. This is approaching 0. And here we have minus 3 times essentially infinity plus 4, this is also positive infinity. Again, if you factor out, if you consider minus 3 e to the power of minus x and minus 4x, if you factor out e to the power of minus x, and you get, and when you apply minus infinity here, this is going to approach, when you apply minus infinity, this is going to approach infinity, and that's going to approach 0. So we have a minus times by infinity, so it's going to be minus infinity. Okay. Again, you can do it more detailed using L'Hopital's rule. So we can conclude that this is approaching minus infinity. Okay. So let's do a rough sketch now, which means the base end behavior is basic. Negative, negative, positive, positive. Okay, so ln of 3 is approximately 1.1. So this is going to be approximately like 0.55-ish. Okay. So let's say 1.1 is here. Okay, I need to rescale that because the graph is bottom heavy. It's mostly at the bottom. So 1.1, let's say then negative 2.4 is there, and negative 2 is there. Okay, so there's 1 point, and half of ln of 3, so right here it's going to be 0. Oh, sorry, it's not going to be 0. When x is 0, it says here it's going to be minus 2. Okay, so when I punch in the calculator, did my rough calculation, when I punch in the calculator, I get 2.2 for the inflection point. Okay, so that's a max inflection point. So after that, it's going to just continue to go up, and here it's going to continue to go down.